Welcome back. And I read on the internet recently that, somebody seemed to know who he was talking about, said that there'll be no need for programmers in 5 years' time. Remember that ChatGPT has only been with us for about 6 months or something, and we're on to the next level already. People are complaining about, it's going to take over the world and do us harm and so on. And I was just wondering how good it is really when it came to programming. So I got sort of mixed results here. And rather than get it to do something from scratch, I thought rather I'd give it a task where I take an existing MATLAB code and just get it to convert it into another language. In this case, I picked Python because I'm not a kind of expert at Python. I've used MicroPython, but the high-level Python I've not really used a lot for scientific programming anyway. So really I'm looking at scientific programming here rather than just text-based type stuff. So I picked one of the examples that was in my book, Rudiments of Signal Processing and Systems, which was a Kalman Filter one, which I got in MATLAB. And just wait till it kicks up. The thing about MATLAB is it deals automatically with matrices, of course. That's probably why it's called MATLAB. And so it's very easy to program in this, but it would obviously be, let's say, a lot harder to program in other languages if it didn't have a means of handling matrices or some kind of library and vectors and so on. So this is my Kalman filter, and if you don't know about Kalman filters, it doesn't really matter in this particular talk, because I've got other talks on Kalman filters and implementations of them and so on, which you can read about. But basically the Kalman filter estimates the state of a system. It's like an observer, but it's for noisy systems. I used to teach this at university to my class in the final year. Sometimes I teach it, not always. And they're becoming more popular now than they used to be. It used to be just used in the Apollo project, and but now they're appearing in embedded systems, for example. But here's a simulation of one where I just simulated a dynamic system. Here's the F matrix. That's like the A matrix in a continuous system. This is a discrete time system, so it's got to be simulated and as such. So it's xk plus 1 is fxk plus d times the noise term, and then it would be y equals h times x. H is the observations matrix, and this is what's called the process noise variance. It tells you how much noise is driving the system, and I just normalized everything to unity there. And this is simulating the system, and then from here onwards is a loop. Not an infinite loop, it just goes around 200 times. So, number of points. And you see that this is calculating the Kalman filter as it's going along its iteration. And the beauty of it is that you can do that in MATLAB. If you were using an older language like Fortran or something, you'd have to write subroutines to do matrix multiplication. That's what we had to do in the old days when we programmed these things. But when MATLAB came out, it suddenly all becomes pretty easy to do, and that's why everybody uses MATLAB. It's doing PhDs and so on in this kind of area. And then, so there's the estimates which I'm storing, and then it's going to plot them with a legend on the northwest. That's the upper left-hand side of the plot. It's going to put state 1 and the Kalman filter estimate, and the second one is state 2. So let me run this. It's called test KF. The listing for this is in my book, as I say. And there it is. So there's the beautiful plot by MATLAB as usual. The red one is the true state, and the blue one, the dotted line, is the estimate of the state. That's for the first state, and that's the second state. It's a second order system, so there's two states. So the Kalman filter works fine. So I thought, let's give ChatGPT this problem and get it to to convert this into Python. So basically what I did is I just took that off and did a Control-C and I pasted it in. So what I did was convert the following MATLAB code to Python and show the complete code. So here it is here. It's just pasted it in. It's in its raw form, so I haven't done anything to it. And then for my information, in my reference, it's gone to Stack Overflow, which is a sort of thing for people who are asking questions on various aspects of software. And it seems to have, I don't know whether it got information itself from there, or whether it's just telling me that I could go there. So it's saying here you can use the Kalman library, but I don't need to do that because I've written my own Kalman filter. Those equations are my own Kalman filter. So obviously it's already got it. Python's got its own library somewhere, but that's not the purpose of this particular problem. And it's asked for another one, a tool to convert MATLAB code to Python. I've got a bunch of MATLAB code from my master's thesis I want to convert to Python. And it says there's several tools for converting MATLAB to Python. It's a small MATLAB to Python compiler. So I guess these are other ways you could do it, but I'm using artificial intelligence. And it says, yeah, here we go. Here's your code. It's done it. I'll have a look at the code in a minute. I'll just copy the code. And I'll go into, I could use Visual Studio with Python, but basically everything, Microsoft's a little bit fiddly at times to get to know. So I'm using this thing called PyCharm, which is I think it's open source really, something like that, way of compiling Python programs. I say compiling, it's an interpreter of course, it's not really compiler. So I'm just going to start a new project. See what it does. Python, select that and just call project 5. I'm still not an expert in this thing, but I get by. There it is. And so just as a default, and it's just going to go high if it's running. So I just click on that test and it says hi PyCharm. So that's my default code. So I'm going to cut that out. I don't know if this is how you normally do it, but anyway, I'm going to do a Control-V for pasting it in, and there is the ChatGPT code. And so you can see it's done matrices a bit like in MATLAB system matrix. So it's copied my code. The T there is transpose, but I didn't know that because although I know the smaller version of Python, MicroPython, I didn't know the higher level stuff about matrices. And the at symbol here again I wasn't aware of. That's when you're multiplying matrices together. So it's already got that built into it, which is rather nice. It had to do reshape there and something. I'm not sure what that is. That's just changing the dimensions of something. And there's a 2x2 matrix for the error covariance matrix. It's creating its own random numbers. I'm hoping it'll be the same. Yes, it is the same covariance. It's sorted that out, I think. I think I put that in. If I didn't, that's easily changed anyway. I think it's the same values. Now here's the main loop. I notice it's indented because it's a for loop in Python. It's a bit like old-fashioned Fortran, where you have to go in so many lines, so it's a bit strange, but it does read a bit quite well. So there's a state equation, x equals f times x plus d times z, and that's a scalar. That's why it doesn't need the at symbol there, because that's multiplying a vector by a matrix, and this is a scalar. I think that's the reason for that. And then this is the Kalman equations written in Python, and then it's updating them. It's Kalman Filter and so on, and then it's plotting. So let's see it, run it and see what it does. And the first thing it would normally do, if you've tried this yourself, is it would complain that it doesn't have a couple of libraries. for example, the matplot library. But I've already loaded that in, so that's very easy to do. You can, it's just in these sort of environments, you just type it in and it finds it and puts it in. So you don't have to go and look for it. It's already around, and you just install it and click a button and it's done. So this is like a copy of the map plotting library that somebody's done. I don't know who did it, but it's all open source. It's been around, I think, for a while. I wasn't aware of it. And NumPy, which is a thing to do with the arithmetic and multiplication and various things, I think, which it uses. It has to have that to do its arithmetic. Anyway, it said there's an error here in line 41. So it didn't get it spot on. And here's line 41. It says there's something wrong there. It says I'm setting an array element with a sequence, and I thought, what on earth's that? So I copied it and I asked it to fix that error. Here's my thing. So that it gives an error code, this y equals setting an array element with a sequence. Please correct the error and rewrite the code in Python. So now it goes through a whole load of stuff and says it's going to look on the internet and find out what it's doing. And so it says when you pass a Python tuple, a list to be interpreted as a NumPy array element. I don't really know. Let's not read all of that. Let's get to the point. So at the end it summarizes it quite well, and it says in the provided code the error is occurring on the line this, which it is, yk equals that. The issue is that h is defined as a 1D array and y is a 1D NumPy array. So the at operator, that's the multiplication of a vector by a matrix or whatever, forms matrix multiplication, and when you try to assign the result to y of k, it raises this setting an array element with a sequence error. To fix this error, you just change the shape of y. So what it's done is it's changed y from just being that to endpoints, 1. That's all it did. So let's copy that and we'll put that in and see what it does. I mean, I suppose I could just change that one line, but no, I'll just put the whole thing in. Run it again. Now this time it seems to have even more errors, but if you look closely at it, you'll see that these errors occur at the plotting stage. It says it doesn't like this thing called lock equals northwest. That's where I put the legend, if you remember, in the original MATLAB code. Northwest. It just means it's on the upper left hand side of the plot. I mean, I suppose I could go back to ChatGPT and so on, but I don't need to, because it tells me here you can't use that. You can use best, upper right, upper left, lower left, so on. So I'm just going to type in upper left for both of these, because they're separate graphs. And run it again. Oh, I've put in upper left. That's what's wrong. Upper left. Let's run it again. And there we go. And it's a little bit of a copy of the MATLAB thing, isn't it? I mean, it looks pretty similar. Fonts looked a little bit different, but it's pretty damn good. There's the original state in red. State estimates. I mean, I don't know if we want to. It won't be the same ensemble, if you like, of noise. Let's just run the other one and see what it does. I mean, it should be different random numbers, so it shouldn't be exactly the same plot. Here's the MATLAB one, but it doesn't seem to be. Yeah, you see, so you can't. It won't. It's not exactly the same. It's not the same time series because it's a different random number generator, obviously. But it's got the same kind of look about it. I'd say the MATLAB one is better, but there's not a lot in it really, is there? I mean, they're both pretty good. So there, it's being able to do it without a lot of hassle at all. Although it's a little bit trickier than it looks, perhaps. I had to change something on this to make it a little bit easier for the ChatGPT to do it when I was doing this as a rehearsal. But it's more or less right. It's managed to do that, and in a very short time, as you can see, it doesn't take very long to do it. Now, if I was to do this myself, not knowing Python, that's going to take me a little bit of time, because I'd have to learn about how to do these arrays using that NumPy thing, or the matrix, the MATLAB library thing that it's got, Matplot. Well, that's the plotting one, I think. But I'm going to have to know how to do all that. And then I'm going to have to understand how to multiply matrices times vectors and so on. So that might take me a day or two to figure that one out. So it's speeded things up incredibly. Then what I thought I'd do is just to show you what's possible, is I just took the Python code and I wait a minute. And I said convert it to VB.net. And I'm not going. There's no way on earth I'm going to put the. I mean, I've used VB.net quite a lot, but I'm not going to run this. But it's converted into VB.net. But it's Microsoft stuff with forms, so you've got to get everything just right there. You can't just cut and paste. You've got to know where it goes. The interesting thing is about it within VB.net is it's created its own matrix multiplication. So it's got, that's the plotting thing. I said it's got to plot it as well. It's using charts to do it. So matrix multiply, it's created its own matrix multiply from 2D from 2x2 arrays, or from in general number of rows, number of columns, starting from 0 rather than 1, of course. MATLAB starts, it's interesting, MATLAB starts from 1, whereas most programming languages nowadays start from 0. Fortran used to start from 1. That's probably where they got it from, why MATLAB starts from 1. But this is the routine for multiplying two matrices to 2x2 arrays. And this rings a bell with me. It's such a, an old thing. I mean, that's what you would have used back in the late 70s, in Fortran. We would have had to have our own matrix multiplications when we did Kalman filters. And now it's got one for transpose, just ij equals ji, that's transpose. Then it's created one for matrix subtract, which is interesting. Well, I suppose we'd have to. Again, it's not built in, then it's got to. It doesn't seem to suggest that there is a library in VB.net for doing matrices. Maybe I would have thought there would have been somewhere, but then it's created another one for matrix add, and that's it. So obviously have a good go at converting into any language you like, really. So will programmers be gone in 5 years' time? I don't know. And if they are, then they'll be replaced by people with who can think problems through and do this kind of stuff, be able to get the essence of a program, then put it in to a compiler and sort out the bugs. So there's still going to be a level of programming. It's never going to disappear, unless the level of AI intelligence goes through the roof, of course, where it can fix all its own problems without us having to say anything. And then maybe the next step would be, which would be fantastic, I don't even have to copy this. For example, I could tell it load this program into the compiler and run it, and that's it. I mean, that would be fantastic. I'm not scared of that. Some people would be, but I'm not really. And then the next stage would be to alter the program as you see fit to optimize it or something, and we'd go off and do that as well. So anyway, that's a brief idea of what you can do with scientific programming. with ChatGPT. You can do that kind of conversion with a little bit of extra work, but not a huge amount. You obviously you don't have to be an expert in the language you're converting it into, but to know a little bit is useful. So again, in the future in learning, you won't need to know everything about the language. You just need to know little bits here and there so you can fix problems and not do anything completely daft. But I would say still knowing the language is always going to be better. Thank you very much.